Hi, everybody.
Okay, sure. Hi. Hey, everyone. I'm Stefan Kader. I work at Canonical. I'm the LXD and LXC project leader.
And I'm James Page. I also work at Canonical, and I'm the technical architect for OpenStack at Canonical. So we're going to be talking to you about deploying OpenStack with machine containers, and Stefan is going to kick off with a bit of an overview of LXD, which is the underlying container technology that we're using. And then we'll go in a bit more on the Nova driver we've implemented as well. So I'll hand you over to Stefan now.
All right. Cool. Come on. Switch. All right. Okay. So what's LXD really briefly? It's basically a new LXC experience. We've been working on that for a couple of years now. It's designed to be really simple. It comes with a completely redone, command line interface. It's got a REST API that you can interact with. You can script it really easily. It's got much clearer terminology than we ever did with LXC. It's really clear what you're doing at any time. It's really extremely fast because it's not virtualization. We're doing containers. As you know, no virtualization overhead whatsoever. Basically raw host performance, with the exception of if you set like resource limits, you might have a tiny bit of overhead from the kernel to do the resource limitation. It's very secure. We use every single security feature that exists in the kernel effectively to make those containers as safe as you can possibly make them without turning them into a full-fledged virtual machine. And it's scalable. It works perfectly fine for your day-to-day development thing, which is what development on your laptop, which is what I'll show you afterwards. But it also scales to thousands of containers, which is what James will be talking about afterwards if you use it through OpenStack. What does it look like? So it kind of usually in a typical LXC deployment, you would have multiple hosts. They each run their own Linux kernel. You might run the same one on each of them or not. We don't really care. You run LXC is the library and that we use to actually talk to the kernel and that we've developed, which is then used by LXD, which then exports a REST API that we have clients for. So we ship with Command 9 tools, is what I'll be showing. People have been writing their own tools, talking to REST API directly. And we've got Nova LXD, which is another client for LXD itself. Now, briefly what it isn't. So as I said earlier, it's not another virtualization technology. We only focus on containers. That does restrict what you can run inside them, but it also gets you like a lot more performance, especially for like idle workloads and that kind of stuff. It's not a fork of LXC. It's by the same team that makes LXC. It's just it was a nice way for us to reset kind of the UX user experience, expose LXC to like a multi-host kind of thing, and add redo a bunch of things. Like it's image-based. Yeah. It's not a fork of LXC. It is using liblxc underneath it. It's the list of what it isn't. And it's not another application container manager in the sense that it's not another Docker, it's not another Rocket. We don't care about running a single process. We don't care about what's running inside your container in any way. We take a full Linux distribution. It's in its system, and that's the extent of the interaction we've got with the inside of the container. So long as we've got an init process that we can exec, we're perfectly happy with it. We don't care what you're doing with your container. So it's really the same way as we would do for virtual machine in that regard. All right, because I'm gonna try and do a quick demo of what we've got right now before James goes on and talk about the OpenStack side of it. So yeah, we've got terminal. All right. So first thing on that machine, I'm just gonna actually install LXD. I'm using the snap package from Ubuntu. We've got a bunch of different ways of installing it on different distros. Anyways, it's installed. It's probably generating keys right now in the background. Well, it's done already. And so we can just do the first configuration step, which is configuring everything. First, I'm going to use ZFS, have it create a new pool for me. called LXD, use it on loop storage right now, default size. I do want LXD to be available over the network, use default address port, give a password, and the rest I don't care so much, I just want default networking and everything. And okay, so LXD is configured and ready to roll. First thing we'll do is just launch an Ubuntu 16.04 container. So it's going to basically grab the latest Ubuntu 16.04 image for the architecture of that system, which is 64-bit Intel. Unpack it, read the metadata from it, create a ZFS file system, because I'm using ZFS as the backend for that particular LXD. We also do BurFS, LVM, and a bunch of other backends. But ZFS in that case, so it's creating a new ZFS file system, which can then be cloned for all your containers after that, making them really, really quick to create. All right, so that's an Ubuntu container created. Now let's do an Arch Linux container, just for good measure. We've got community maintained images produced daily for a lot of Linux distributions. We've got Alpine Linux, Arch Linux, Debian, Gentoo, Fedora, CentOS, Oracle Enterprise Linux, probably forgot a few. So there's a good chance your distro, and particular version of that distro is already available. All right, so I've got those two containers created now. That sadly doesn't really quite fit in the screen, but well, if I make it slightly smaller, it might. Well, whatever. But we see two containers running. They've got the IPv4 address, IPv6 address, fine. Now, you can exec a shell inside the Ubuntu container, which we've done. Can look at the process list inside there. We basically see init process and the usual systemd, suspects, and cron and SSHD and kind of stuff. But it looks like a full system. Now we can go look at things like CPU info. If I grep, whoops, come on. Okay, prox info grep. All right, so we see we've got eight processors on there because that's what the physical machine has. Disk space, we've got the old system right now, so it's the 42 gigs we saw earlier. And memory, we've got 12 gig, that's what the host has. But we can change that live as we want. So we want 2 CPUs, we want 1 gig of RAM, and we want a disk limit of 5 gig. Go back inside the container. Disk space is down to 5 gig. Memory is now down to 1 gig. And if I look at CPU info, we're down to 2 CPUs. So that's resource management with LXD. We can also do resource block I/O limits for IOPS to particular devices. We can do bandwidth limit for network, all that kind of stuff. All of that stuff can be applied live to our containers. All right, now we've had that second container, Arch Linux. Can create a snapshot of its current state with snapshot. Then we can get a shell inside there, and let's install something like Apache. So, okay, Apache is installed. We can query that to make sure that it is. And now let's just restore the snapshot to its for that container. There we go. And if we query, it's gone. So you can snapshot and revert extremely quickly. It takes less than a second to snapshot, less than a second to revert anything. So that's like your normal snapshot story. Now, LXD, our command line client tool, can also deal with multiple hosts. So I've got another server that I can install Git flags. I do LXD remote add to add a remote server. That adds it to the list of the remotes I've got in my client. And I can now do things like list what's running on that remote server, which is nothing, and say I want to start an Alpine container on there. That's done. Can get a shell exactly the same way. That's done over the network this time. And let's create some random file on file system and fire off that container. There we go. I can now move that container to my other host. So I'm just transferred over the network. It did the ZFS and receive optimized file transfer. And we see it's now on the same machine that's running the Arch Linux and Ubuntu container. And I can just start it again here. Get my shell in there, and the file is there.
There's some questions?
Can you change the contrast on your terminal?
Maybe.
Maybe black and white or something.
Yeah, I can try. The problem is it's going to break my back to try and figure that out. Yeah, let's see. What does that do? There we go. All right. Last thing I've
So
got.
there was one other question, which I assume wasn't change the contrast.
Right. Yeah.
So the question is, can you live migrate containers between hosts?
Right. You can live migrate containers between hosts with LXD. Yes, we do integrate with Creo. We've been doing some work on it. The fact is, we've not been actively maintaining Creo. It's like a beta kind of state feature, where if we do have interested customers, we'd be happy to ensure that your particular use case works. But live migration in Linux means you need to be able to serialize all the kernel state of your workload, which is rather tricky. And so we can probably make it work for your particular use case if you really care about it, but making it work generically for everyone is something we just don't have enough people to get done, unfortunately. But yes, we do integrate with Creo. If Creo works, then you can live migrate containers as they're running. It's simply, if the container is running and you LXC move, it's going to serialize state, move it, restore it. All right. Okay, I'm going to try and do the last demo really, really quickly before it's James' turn. On my local laptop, one thing that we can do is also device pass-through. So I've got another container called Android, in which I can do ADB devices. It's going to show me that I've got nothing. There we go. I can add a USB device to it. It will still show me that I've got nothing because my phone is not plugged in. So now if I plug my phone in, I unlock my phone, and I run ADB devices again. Now my USB device has been passed into the container, and I can get an ADB shell, and we can see that the cell phone has been passed into the container. So we also do that for GPUs. You can pass the GPU into the container if you want, and the right dev NVIDIA or dev DRI nodes will be automatically passed for you. All right, back to slide. So really briefly, before we go to Nova LXD, just quick recap. LXD operates on system containers, so we run full Linux distros exactly like a virtual machine, but using containers on Linux. With a really simple REST API to drive all of that. You could drive basically all I did through curl pretty easily. We do daily images of most Linux distributions, and LXD itself is available on a whole bunch of distros. Obviously, main focus is Ubuntu, but it's available on Debian through a snap. It's available on Arch Linux through a user repository, and we've got native packages in Gen 2 and Alpine Linux, as well as someone's maintaining some packages in user repository for Fedora. That's it on my side.
Okay, thank you.
So, all right, and for the demo, you just have to do this. All right.
Okay, so Stefan's gone into machine containers and how we manage them with LXD. So I'm going to talk about how we've integrated LXD into OpenStack with a Nova driver. Okay, so if we look at KVM, we've got a number of guests running here. We can pretty much simulate exactly the same thing with LXD. Those guests are much lighter weight. There's no simulated firmware, BIOS. It's running on the host kernel, and it's just resource controlled via LXD and the various kernel mechanisms available to it. And we can slide OpenStack between those things to provide a management layer. So because LXD container is a machine container, it has very similar semantics to a libvirt KVM virtual machine. So all the things you'd expect to do on an OpenStack cloud to a KVM instance, you can do pretty much all of them to a LXD container running on a cloud as well. So the kind of normal lifecycle management for managing machines, and also resizing, snapshotting, plugging into virtualized networking. So whatever SDN you're using on OpenStack, we can pretty much plug into most things these days. And we plug in using the same semantics as a libvirt KVM driver, but without the virti OA layer and the overhead that brings as well. We can also apply resource constraints to containers. So Stefan demonstrated doing that on the fly by reducing the number of processor and memories down, but we basically can take the flavor mechanism in OpenStack and we can apply that to containers as they're created. So memory, CPU, we apply quads to I/O operations. And in the same way we can apply resource controls to the resources on the machine the container's going to consume, we can also secure the machines with the standard security group mechanisms available in OpenStack. So either IP tables firewalls or native Open vSwitch firewalling work just fine with a LXD container managed via OpenStack as a libvirt container. And we can migrate containers between hosts. So Stefan demonstrated this at the LXD level, but we can plug into the Migrate API in OpenStack as well. And we can also do a kind of neat trick of exposing the entire hypervisor as what we call an exclusive machine container. So it gives you the whole machine, but with the container abstraction layer around the processes that the user is going to be consuming on the cloud. So they're getting the bare metal performance, they're getting the benefit of being able to plug into whatever SDN is used on the cloud, but without the operational overhead of having to give someone a physical server and the complexity that brings in terms of compromising firmware, compromising BIOS, and the hygiene you'd have to do as a cloud operator to be able to manage hardware that you provide to tenants. Okay, so I'm not doing a live demo, unlike Stefan.
Windows tab.
Go for it. And I pre-recorded mine this morning because I was spinning chicken. Okay, so we've got a Nova LXD deployment in one of our labs. So we're just going to SSH into that and take a look at it. Right, so the normal trammel about getting access to your cloud. Let's take a look at the services we've got running. This is a 3-compute node cloud. We've got 3 hypervisors, and our control plane is actually in LXD containers on top of those as well. I'm not going to talk about that today. So let's have a look at one of the hypervisors. You can see about halfway down on the second column, this is a LXD hypervisor type rather than a QEMU hypervisor type, which is what you typically see with libvirt. We'll also have a look at the neutron agents running across the cloud, and you'll see that, although that's wrapped a little bit, we can see the Open vSwitch agents and the normal L3 and DHCP agents that we run on network nodes. So from a kind of topology perspective, the cloud looks very familiar to anybody who's ever deployed a libvirt KVM-based cloud. So we haven't got any instances running at the moment. So we'll boot a couple of instances, a small one and a large one. I'm too slow, obviously. Here we go. And they should be running pretty quickly. But I can't type fast enough, obviously. Why doesn't ASCII seminar trim the gaps? But yeah, so those instances are booting, and they should be both active and running. They're just plugged into a private network, which in this case is a GRE overlay network on the back end. So we're using the ML2 Open vSwitch plugin for the networking on the cloud. So we need to add some floating IPs to be able to access these instances. So last octet there is 161 for the small, and should be 140 when we get there for the large instance. And now we should be able to access them. Oh, no, we won't. I haven't done the security group bit yet. So right now we can't ping the instance because it's completely firewalled off from the outside world. So we'll just have a look at the security group. So we've got the standard egress security group rules that all profiles come with in OpenStack. So we'll add ping and SSH ingress from the outside world into the default group, and then we should be able to access the instances just fine. Okay, so we're getting a ping from it, so just check the other one as well. And let's log into one and have a look. So have a look at the CPU info. You see we've got can't see how many cores we've got there. Is this the small? It's the small. It's got 1, and it's got 2 gig of memory, which is off the top. Yeah, I got this one earlier. So, no, it's still off the top. So, it's got 2 gig of memory. And you can see the process listing there. It's much trimmed down as there's no kernel processes running, but all the normal things you'd expect in a full system like SSH and syslog and cron and all the other things you need to operate an instance are there. Can I ask you a question in the end? Because this won't wait for me, unfortunately. You can see we've got an IP address that's being presented by the LXD layer, and we can see the private IP address there that Neutron has allocated for the instance. And we'll have a similar check on the large instance as well. We might get to see more CPU information here, but let's see. No, because the number's off the top. But again, this is an 8 gig machine with 4 cores rather than the 2 gig machine with 1 core that the other one had. And similar process listing as well. So hopefully that gives you a flavor that like using a LXD machine container on an OpenStack cloud is a very similar experience to what you would expect with libvirt KVM. There are still some gaps. Storage is still not a strong point. We have basic support for the Cinderized SCSI driver, and we're working on support for a Ceph driver this cycle as well. So that should be available in the Okata release towards this end of this month. So we'll quickly talk about benchmarks. So Stefan alluded to the fact that you're getting very much bare metal performance. So we've got a few benchmarks to go through, just 3. This is the Hadoop TerraSort benchmark, and this is using the exclusive machine stuff I was talking about earlier, where we give a full machine to a container or a KVM instance. So we looked at the total runtime, and bare metal and Nova LXD come very, very close. I think the diff there is mainly due to use of overlay networking and the overhead that brings in at the networking layer. KVM took quite a bit longer. We had a number of failed jobs that had to be retried, so that it did push things out. And I've got a few latency things as well. So Cassandra Stress has lots of small writers. So we can see write latency with LXD compared to KVM is much, much lower. And again, that results in much, much higher throughput for a Cassandra Stress benchmark. Okay, so I think we've got about 3.5 minutes left now. So if anybody's got any questions, please put your hand up and I'll repeat them.
A couple of questions. Can you use LXD to pin to a CPU?
So the question is, can you use LXD to pin a container to a particular set of cores on the host, so it's doing CPU infinity. Mm-hmm. So Stefan, do you want to answer that at LXD level?
Yes, we absolutely can. The CPU limits we set, if you just give us a straight number of CPUs, we will do load balancing for you, but if you give us a range, say 1 through 4 or 1, 3 to 4 or something, we will pin you on those particular cores, yes.
So the second part of that is that can you do it through OpenStack yet? Not yet, but we will support the full set of flavor properties that allow you to do that probably by the end of the Pike cycle. So another 6 months yet.
First question is, do you support container resize?
Yes.
So, obviously LXD, as I was showing, you can set everything live, and that means that you can do resize pretty easily.
Yeah, and you can hot plug as well. So if you want to add additional ports to an instance, you can use the standard semantics via the OpenStack APIs to be able to add additional Neutron ports to a container, and that's done as a hot plug event and is picked up as in the container appropriately.
And the second question was about whether we support the OCI initiative. We don't, because they mostly focus on application containers. They don't care about running a full distro. So it's not been a great fit in general. For LXD specifically, we've been looking at some parts, like the OCI SDN and some of those aspects that could be useful for us. But the image side of it, it's not a good fit because we care about like a full, pristine distro image coming from the vendor, as opposed to having image source and people doing layers and stuff.
Okay, there's one at the back, and then you're next. Yeah.
In your example, you showed that you did passwords to a container. A password of a physical device to a container. Do you use the IO MMU in order to do that?
Okay, so the question is, the device pass-through, was that using IOMMU? No, it's not, because we're using the same kernel as the host, so we're not passing. You can't pass a PCI device into a container just like you can't load a kernel module inside a container. What you do is the kernel module itself runs on the host. in this case, was giving me dev bus USB devices, and those were being passed into the container. Same thing when you pass a GPU, the NVIDIA driver would be installed on the host, would get to dev NVIDIA devices, then LXD would pass whichever of those dev NVIDIA devices you need for the container to use. The driver runs on the
same
kernel
would apply
host.
to something like an SRIOV virtual function, in that it presents as a host device, and that can be mapped into the container.
Then the device using DMA transactions trying to everywhere in the host memory basically and escape the container.
The question is about the risk of DMA attacks against the host. If you do pass a device that gets you access to the entire host memory, yes, you can absolutely read dual memory. You have to be careful as to what you pass into the container. All right, time's up. If anyone wants, we've got a bunch of stickers here that you can come and collect if you're collecting stickers. And thank you very much.
Yeah, thank you.